Hello, welcome to Test 1 Review, Math 1530. So, on the day of the test, you'll go into, I'll have an extra tab in Blackboard open for tests, and you'll go in there and I'll post the test in there, and you'll have to download it. You'll also have to log into WebEx so I can watch you and make sure you're not using outside sources. So you can't use your notes, you can't use your book, you can't use like a high-powered calculator. You have to use a scientific calculator, and I'll be checking to make sure you're doing all that. So you'll either print out the test or you'll write your answers on some paper. And then you'll have to, once you're done, you'll upload the test somehow, so either a scanner or using a phone, and then convert that test into a PDF form. And I have some links there that can help you do that. If you have a scanner, it kind of already does it, but if you're using your phone, you kind of have to use a special app, I think, to do that. If you're taking like pictures with your phone, then you got to take the pictures and turn them into PDFs. If you don't do that, my email is going to get blown up, okay, because the amount of data being sent into there will just overwhelm it. So I've tried it before with doing just hey, everybody send me pictures, and it's a nightmare for me on my end. It's not bad if I have just like 10 students, but once I get now with into the 60s and 70s, and then with a number of students sending me things, and each student sends me 10 pictures, it's just 700 pictures. No. So you gotta convert these things to PDF. I advise you to do a test run before the day of the test. That way, when the test happens, if you have an issue, or hopefully you then won't have an issue if you do a test run, like a dry run before the test. I honestly, I absolutely want you to do that. Do a test run before the day of the test. So download a document, any document, maybe download last year's test, and then see if you can take pictures, upload, scan it, and see if you can attach it to an email and send it to yourself, okay? If you decide that you're going to do this on the day of the test to me, it's going to take extra time, and I'm going to wonder if you're just kind of cheating, like, oh, I can't figure it out, and at the same time you're sitting behind the computer quickly copying answers out of the book or something. No, don't do that to me. Figure it out before the test. Okay, so there's my spiel. So my tests are pretty straightforward. It's extremely similar to the review. I usually take my questions directly from the book. If not, I'll just switch the numbers around a little bit. And so, for example, in P7 where we started, and the test will be over P7 to 1.9. Okay. So in P7, what I would advise you to do is look at problems 1 to 25 odd, and then 91 to 123 odd. Okay, so look in there and make sure you can do those types of problems, because those are the types of problems that I'm going to pull and put on the test. In particular, I'm going to go ahead and look at some random samples from that section in order to give you a good idea of what you're looking at. So I won't put any like the super hard problems on there. They'll all be kind of in the middle of the road. So let's take a look. Okay, so number 9, and this section was all about solving equations. So here we go. This thing is a linear equation. Okay. And a good way to practice for the test is just go into the ebook and look at their exercises and maybe do if I give you number 9 in the review, try number 8, try number 10, try the problems around the ones I'm giving you in the review. And that's usually a pretty good way to study. Okay, might not be perfect, but it'll probably guarantee you a pretty good grade. So anyways, first I want to simplify both sides, and that means I have to distribute first. Okay, so on the left-hand side, I'm distributing the 3. On the right-hand side, I'll distribute the 2. Let me expand the screen a little bit so we're Okay, so it'll be 3x, negative 6 plus 7 is plus 1. On the other side, I got 2x plus 5. Then I'm going to collect the x's on one side. So I have x plus 1 equals 5. And then subtract 1 from both sides. And x is 4. Okay. You don't have to write it in their notation with the sets and everything. That's fine. Just put x is 4. There's my answer. Okay. On to the next one. You have to show work on your test. Okay. If you're just writing the answers, no, I'm just going to mark it wrong. And then I'll ask you to come and talk to me during my office hours. So you got to show your work. Otherwise, I'm going to think like a calculator did it for you or something. Okay. So there's a lot of issues, you know, considering that we're all online and everything. We have to make sure we get the academic integrity going. So it's much easier when we're all in the classrooms. But I apologize if I do inadvertently think that maybe you're doing something and you're not. Here we need to first state the restrictions. With rational equations, you got to state the restrictions. So you take the denominators and you set them equal to 0. So x plus 1 equals 0. So x can't be negative 1. X minus 1 equals 0. X can't be 1. And then the last guy, x squared minus 1 is 0. That's a bit redundant, right? Because that's just going to be x minus 1 times x plus 1. And you'll get negative 1 and 1 for restrictions, which we already have. Okay. Make sure you note the restrictions for me. So put it in a box. I usually put R for restrictions. Okay, so I have to see those restrictions or you will lose some points. Okay, what am I going to do now? So now I'm going to multiply through to get rid of all of the fractions. And that means to multiply by something that's divisible by x plus 1 and x minus 1. On the right-hand side, it sometimes helps if you go ahead and factor that, right? So let's go x minus 1, x plus 1. Okay, so on both sides, I'm multiplying by x minus 1, x plus 1. Over here, x minus 1, x plus 1. Okay, distribute on this side. On the first product, you'll have the x plus 1's canceling and be left with 2 times x minus 1. Minus, and the second product you'll have the x minus 1's cancel and you're just left with the x plus 1, 1 times x plus 1, which is x plus 1. On the right hand side, the x minus 1 and the x plus 1's both cancel, so you'll just be left with 2x. Once it's in this form, you can go ahead and simplify. Okay, so I need to distribute the 2, and here I need to distribute the negative 1. On the right-hand side is 2x. Combine like terms, 2x minus x is x. Negative 2 minus 1 is negative 3. 2x over here. Move the x, right? Collect all the x's on one side. So you get negative 3 equals, I guess just x. In other words, x is negative 3. Always check that against the restrictions. This guy is not a restriction, so we're good to go. Okay, that would be our answer. So circle it, make sure I know that you know what you're doing. Okay. All right. Let's take a look at this guy. So this guy's a radical equation. So for radical equations, you try to isolate the radical and then square both sides. So I'll move the radical to the other side. So 5 plus radical 2x plus 5. And then I'm going to square both, whoops, I don't want to, let me move the 5 over. So I haven't really isolated the radical, right? So I need to get this guy all by itself. So I'm going to move the 5 to the other side. So I have x minus 5 is root 2x plus 5. And then I'm going to go ahead and square both sides. Okay. The problem with squaring both sides is now you have extraneous solutions potentially. And you're going to have to check your solutions at the end. Okay. On the left-hand side, you have a FOIL. Okay, so that's really just x minus 5 times x minus 5. So I'll have to FOIL that. On the right-hand side, the square root will go away. Okay, so I got to FOIL this side. X squared minus 5x minus 5x is minus 10x. and then plus 25 equals 2x plus 5. Okay, move the 2x, move the 5, so you get x squared minus 12x plus 20 is 0. Okay. Try to factor that thing, so you get x, hopefully 10 and 2, right? So x minus 10, x minus 2 is 0. And then we can set each equal to 0 and solve. So one potential solution is 10, one potential solution is 2. Okay, and then we need the check. So you have to check these. So for x equals 10, I'm plugging 10 back into the original equation. Okay? So I'll have 10 minus the square root of 2 times 10 is 20, plus 5 is 25. And I got to make sure that's the same as 5. So I have 10 minus square root of 25 is 5, and it seems like that one works. Okay. So I'll put a check mark there. The other guy, so I'll have 2 minus the square root of 2 times 2 is 4, plus 5 is 9. And then we got to make sure that's the same as 5. Okay, so 2 minus 9, the square root of 9 is 3. 2 minus 3 is negative 1. And that is not the same thing. So we just have one solution. So I'll mark down x is 10, and I put it in a circle. And that's it. Okay, so just make sure you somehow note that the 2 is not a solution and that 10 is. Okay, P9 was all about inequalities. So linear inequalities and then absolute value inequalities. I'll be taking problems like number 27 to 91 odd in the book, the e-book. So for example, 39, let's take a look. 1 minus x plus 3 greater than, or equal to 4 minus 2x. So as we go through these problems, it's a good idea to kind of pause the video and see if you can do it on your own. When I do the solution for this one, I want my answer in interval notation. Okay, so you need to do that as well. Okay, so first I'm going to clean up both sides. So distribute the negative. And combine like terms. So negative x minus 2 greater than or equal to 4 minus 2x. Collect the x's on one side. Plus 2x on both sides gives me x over here. Minus 2 greater than or equal to 4. And then finally add the 2 to both sides. So x is greater than or equal to 6. And then if you need to do like a number line, here's 6. It's everything greater than that. Okay, so it'd be 6 to infinity for your final answer. And yeah, that's it. But be careful. Obviously, if you have to multiply or divide by a negative, you got to change the direction of that inequality. Okay, so that's the only real difference between this and a linear equation. Okay, we also have the absolute value inequalities, so stuff like x minus 1 greater than or equal to 2. And there's rules you have to follow, right? The order of operations is very, very important in mathematics. If you do it the wrong way, it won't work. And that's true a lot in our human realm as well. If you put on your shoes before your socks, you may be in trouble, okay? So in this case, you have to go x minus 1 less than or equal to negative 2, or x minus 1 greater than or equal to 2, positive 2. Okay, so I'm going to add 1 to both sides, x less than or equal to negative 1. Yeah, so that's one interval, and then the other interval, add 1 to both sides to get x greater than or equal to 3. Okay, so I need to write my answer in interval notation, and again, if you need a number line, go by all means. So everything less than or equal to negative 1, and then everything greater than or equal to 3. Okay, so we'll have negative infinity to negative 1, and then you have the union together with the interval 3 to infinity. So your solutions to that absolute value inequality are going to either be in this first interval from negative infinity to negative 1, or the second interval from 3 to infinity. Okay, let's look at another one. So 3 times the absolute value of x minus 1 plus 2 greater than or equal to 8. Okay. To figure out how to get rid of the absolute value, we first need to isolate the absolute value, this part. Okay. There's no way around it. So what I'll do first is to subtract 2 on both sides. Then I'll divide both sides by 3. Okay. And then I basically have the exact same problem that I had previously. So I kind of already have my solution, right? That's just that inequality. So the solution must be negative infinity to negative 1 unioned with 3 to infinity. I'm sorry, that example was a bit silly because it ended up with the same. So let's do one more. Okay. Number 85. So this one looks kind of kooky, but it's not. Okay, it's just written backwards. So if you read it, it's 5 greater than the absolute value of 4 minus x. If you read it in reverse, it's the absolute value of 4 minus x less than 5. Okay, so this is a second type of absolute value inequality. And for these types, what you can do is drop the inequality and write it as a compound inequality. Okay, so you'll put 4 minus x in between 5 and negative 5. Okay. Then you try to isolate x. So I'm going to subtract 4 from all 3 sides. Okay, so I get negative 9 less than negative x less than 1. And I'm going to multiply all 3 sides by negative 1. But if you multiply by a negative, it changes the direction of the inequality. Okay? And it changes all 3 inequalities. The way it's written right now is not correct. You always want to go from the lower numbers to the higher numbers, right? So what we do, instead of writing 9 greater than x greater than 1, I write 1 less than x less than 9. Okay, and on the number line, you can kind of, I mean, ultimately we have to put it in an interval notation. Okay, so here's 1, here's 9. On the number line, it will look like this. Okay, where we don't have the line underneath the inequality, so we use the parentheses instead of the brackets. And so our solution is the interval from 1 to 9. Or is that negative 1? Right, whoops, yeah, so when I multiply by a negative, that should be negative. Sorry. Okay. Okay, so that process for taking absolute value inequality and getting rid of the absolute value, so in the first case we have to split it into 2 inequalities when it's a greater than type. This other case, you split it in, well, you don't really split it, right? You just turn it into a compound inequality like this. You have to do it that way. There's no way around it. There's no easy way to do it. It's just hard, okay? It's hard to remember it sometimes, but you got to. Okay? You got to figure out a way. The next section I want to look at is then 1.2. So I'm not going to include 1.1. So if it's not in my review, it's not going to be on the test. Okay? So there's no 1.1 on the test. We'll just skip in the 1.2. Okay? So 1.2, I'm talking about questions like 27 to 37. And here we're talking about functions, evaluating functions in particular. So something like 29. And I think I had a quiz on this in one of our mini lectures. 2x plus 3. So we give you a function, and then we want you to evaluate the function at particular values. Okay, so g of negative 1. So wherever you see x, you're putting parentheses negative 1. So again, a reminder, negative 1 squared is not the same thing as negative 1 squared. And if you try to pretend like it is, I'm going to mark off a point. Okay, those are not the same things. It's like the difference between a comma and a period. You got to know that. Okay, you're not going to get through life if you keep putting periods instead of commas and vice versa. So it's the same deal here in math. A lot of math is just about communicating to other people. So sadly, we have to kind of follow these norms. So anyways, negative 1 squared is 1. Negative 1 times 2 is negative 2, and then plus 3. So yeah, what? 4 minus 2 ultimately is 2. Okay. So not only can we evaluate functions at numbers, we can put other expressions inside of the functions and kind of transform those expressions into something new. So in this case, I'm putting in x plus 5 wherever I see x. So I'm going to put, instead of x, and you can even write it like this. Wherever I see, so above, that would have been the first parentheses would have been an x, the second parentheses an x. So instead of x, I'm going to put the x plus 5 there. Okay. The first guy is a FOIL, so I got to FOIL that x plus 5 times x plus 5. And then the second guy, I can do that. It's just a distribution, 2x plus 10, and then plus 3. Okay, so I got to FOIL the first is x times x is x squared. The outer is 5x. The inner is 5x. 5x plus 5x is 10x. And then 5 times 5 is 25. It's 2x plus 10 plus 3. So it's not enough just to write this first statement. I mean, I'll give you a point for that, but you have to simplify it, okay? Simplify it because in the long run, you're going to be using this stuff to do other stuff. So if you don't simplify it, you're going to have a complicated nightmare on your hands. So we want to simplify the heck out of it. 10x and 2x gives me 12x. 25 plus 10 is 35, plus 3 is 38. Okay, and then that's as good as you can do. Those are all unlike terms, so you can't combine them. Let's look at one more. So we want to plug in negative x wherever we see x. Okay, so again, you could set it up like this with parentheses, right? So that's wherever you put x, wherever x was, just put some parentheses there. And then you can fill in the blanks with this thing that I'm putting the arrow at, right? So you just put negative x in all these blanks. Good to go. And now multiply negative x squared is negative x times negative x. So that'll be a positive x squared. 2 times negative x is negative 2x, and then plus 3. And no more like terms, you're kind of done. Okay. Okay, let's look at one more in this section. This is 35. We have f of x equals 4x squared minus 1 all over x squared, so a rational function. Let's look at f of 2. All right, so again, you could set it up like this. You could put parentheses wherever x was, and then just fill in the parentheses with this thing. Okay, so there we go. There it is. So order of operations, please excuse my dear Aunt Sally. Exponents first. So 2 squared is 4. This one, all over 2 squared is 4. And then multiply, so 4 times 4 is 16. All over 4. 16 minus 1 is 15. All over 4. Okay. Let's look at B. F of negative 2. Okay. So again, you just leave some parentheses there and then plug it in. All right, so I'm going to put a negative 2 there and a negative 2 there. Order of operations. Negative 2 squared again is 4. All over 4. We're going to get the same answer. That's the same thing as the previous one. Okay. Let's look at C. So this time we want to put in negative x. Okay. So I got 4 times negative x squared minus 1 all over negative x squared. Negative x squared is just x squared. This 1 all over negative x squared is x squared. Okay. So if you plug in just to the side, this is the answer, but just to the side, f of negative x here in this case is equal to f of x. That of course means it's an even function. Okay, it's symmetric about the y-axis. Okay, let's move on to 1.3. And in 1.3, we introduced the idea of even and oddness. There's also piecewise functions and some more with evaluating functions. So let's take a look I'll in particular want problems like 37 to 47, 59 to 69, and all odd, and then 71 to 85 odd. So 43, let's take a look at this guy. F of x equals x squared minus x to the fourth plus 1. I want to determine if it's even or if it's odd. So the check for evenness is if f of negative x equals f of x. Okay, if it's odd, then you'll end up with f of negative x equaling negative f of x. Okay? And it's possible it could be neither, right? If it's neither of those cases, it's just neither even or odd. So anyways, let's take a look. So I'm replacing x with negative x, and then if I plug that in there, I get negative x squared minus negative x to the fourth, and then plus 1. Negative x squared, negative x times negative x is positive x squared, minus negative x to the fourth is x to the fourth, and then plus 1. This is exactly as the same thing as what we started with, f of x. Okay, so in other words, we have, so f of negative x actually equals, via all of this algebra, f of x, and so f of x is even. Okay. Okay, you need to show me the work. I realize that if you have a polynomial and all the exponents are even, it is an even function. But I need to make sure you can do this. The issue is I don't want to give you a really hard one and have everyone fail miserably at it. I want to give you an easy one that you can do and show me the work and show me you know how to do it. Okay, so you have to show me the work. Show work. Okay, so that's 43. Let's look at an odd function, see what happens there. This is 47. So f of x equals x times the square root of 1 minus x squared. So again, you just plug negative x in for x. So we have negative x there, and then 1 minus negative x in here. And then simplify it. So I have negative x times the square root of 1 minus negative x squared is x squared. So I get that. And what is that? Well, that's a negative times f of x. Right? So in this case, we have f of negative x equals negative f of x. And so f of x is odd. Okay, right, so let's move on. Piecewise functions, you should be able to graph these things. So 63, f of x equals x plus 3, and then x minus 3. So it's x plus 3 if x is less than negative 2, and then x minus 3 if x is greater than or equal to negative 2. So you can do some t-tables, and for the parts, you want them to, you want to include the x value negative 2, where the two parts meet each other. So I'm going to include negative 2 as one of the values in my tables for these functions, right? So the first one is y equals x plus 3, and the second one is y equals x minus 3. Okay? And so I got to include negative 2 here. If it's a less than without the line underneath, you're going to use an open dot. If up to the on the right to the side here, I'm writing that in. If the line is underneath the inequality, then you're using a closed dot. Okay. Let me get some extra points here now. So let's go with negative 3. So negative 3 plus 3 is 0, and then negative 2 plus 3 is 1. Negative 2 minus 3 is negative 5, and then we'll try 0. 0 minus 3 is negative 3. Okay? And then we just draw the thing. All right, so let's get some points going. Negative 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Negative 3, 0. 1, 2, 3, 0. And then negative 2, 1, and I need an open dot there. Okay, so that's just a straight line. And then negative 2, negative 5, I need a closed dot there. and then 0, negative 3 goes through that point, and we have this thing. Okay, and there it is. Okay, evaluating functions. So number 73, f of x equals 3x plus 7, and I want to evaluate this thing, f of x plus h minus f of x all over h. Okay, so what is this thing? This thing is like a slope formula. Okay, it is a slope formula. As a matter of fact, it's going to give us the answer, which is the slope of that line. It'll give us 3. Okay, so our job is kind of to prove that. This is just the slope thing, or at least give some evidence to that fact. So how do we do this, right? F of x plus h, this first term here, how do I get that? Well, I'm going to put x plus h in for x, all right? So I'll have 3 times, blank plus 7, and you're putting x plus h in for x. Okay. Then it's minus this other thing, let's box it in red. Okay, so minus all of f of x. So you have to put that in parentheses as well. So all of f of x is 3x plus 7. And then it's all over h. Okay, and then your goal is to kind of just simplify the heck out of it, hopefully get rid of the fraction. So what do we get? Distribute 3x plus 3h plus 7, distribute minus 3x minus 7 all over h. So 3x minus 3x is, there's 0. You usually get a nice cancellation, like what's going on here, right? 3 times h over h. H over h is the same as 1 over 1, so you get 3 times 1 over 1. 3 times 1 is 3 over 1. 3 divided by 1 is 3. So yeah, we get the slope. It's just a high-powered slope formula that you're going to need for calculus. Okay. All right. Half of calculus is just about dealing with slope. Believe it or not, they have a nice fancy term for it. They call it derivatives. Like, oh, look at how smart we are. But it's just slope. Don't let it intimidate you. You want to take calculus? Take calculus. People think you're smart, right? It's a good thing to have, even if you're like an art major or something. I know some artists who went and got their PhDs in mathematics, and I mean, my cello teacher had his PhD in physics. So the sky's the limit. Don't limit yourself just because you want to like fit into a certain category. Go out there and learn what you want to learn, and make the world, I don't know, conform to what you are. People are so apt to put themselves into some category, like I want to be this or I want to be that. Okay, I'll shut up. 1.4, this is all about slopes and lines. The 1.4 and 1.5 are all about slope and lines. So we're looking at problems like 11 to 37. For this section, you're going to have these formulas memorized. You need the point slope form, the slope intercept form, and of course you need to know how to figure out slope in the first place, which is just y2 minus y1 all over x2 minus x1. So that stuff, memorize it. Okay, you're not allowed to have notes on the test. You're not allowed to have your book. Okay, all right. So these problems, how do they go? They'll give you some information, and you have to create the equation of a line in slope-intercept form, which is this form. Okay, so m equals -1, and then we have -1/2, -2. So I'm going to start with point slope form, right? So y minus y1 is m times x minus x1. And I'm just plugging this material in. This is x1, this is y1. Okay. So I have y minus -2 is -1 times x minus -1/2. Y minus -2 is y plus 2 equals -1 times x plus 1/2. You want to get it in this y equals form. So you're trying to solve for y, basically. I have to distribute, so I get -x minus 1/2. Move the 2 over, I get y equals negative x minus 1/2 minus 2. 2 is the same as 2 over 1. I need a common denominator, so I'll multiply top and bottom by 2. So y is negative x minus 1/2 minus 4/2. So finally, my answer, y is negative x minus 5/2. Okay. Let's look at another. So in problem 31, what they're doing is giving you 2 points, and then you got to do the same game. Okay, -3, -2, 3, 6. Okay, so we need a slope. In the last problem, they gave you a slope, right? Now we need to find that slope. So, you know, go m equals, and I go y2 minus y1. I always draw these brackets to help me keep things in order. And then 3 minus -3. Okay, so the top will be 6 plus 2. The bottom is 3 plus 3. That'll be 8 over 6. Simplify it, you know, simplify it before you use it, so, because complexity snowballs sometimes. If you got something that's complicated and you start using it, things will just get more and more complicated as you go. So simplify, okay? What else? And now I need to put everything in this point slope form, right? So all I need is a point and a slope. I'll just take the first point up there and use that for my x1 and y1. So I have y minus -2 equals 4/3 times x minus -3. Maybe I should use the other point, right? Y plus 2 is 4/3 times x plus 3. What do we got? Y plus 2, I got to distribute this 4/3 equals 4/3 x plus 12/3, right? So 4/3 times 3 is the same as 4/3 times 3 over 1. 4 times 3 is 12, 3 times 1 is 3, so 12 over 3 is 4. 12 divided by 3 is 4. Okay, move the 2, so we get y equals 4/3 x plus 2. That'd be our final answer. All right, so some of that stuff. 1.5 then is all about the parallel and perpendicular ideas. So we're looking at problems like 5, 11, and then 13 to 17. Odd. Number 11, they want you to create the equation of a line, and either in slope-intercept or point-slope form is probably fine. I'll read the directions on the test. I know it's sometimes you forget to read directions. I do too. But read the directions. Number 11, we want to create an equation of a line that passes through the point 4, -7, and is perpendicular to the line x minus 2y minus 3 is 0. Okay. So we need 2 things, right? We need a point, and they gave us a point. They gave us 4, -7. Then we need a slope. Okay, this takes a little more work. You can't just read the slope off of the line. Okay, if you did read something off the line, it would be wrong, because you have to find the slope that's perpendicular to that given slope. So our first step is to convert this thing into a form where we can read the slope off of it. Okay, because the slope, if you think it's the thing in front of the x, you are wrong. It is not 1. Okay, we have to convert it into slope-intercept form, right? So I need to solve for y. So here we go. X minus 2y minus 3 is 0. I'm going to move the 2y to the other side, so I have x minus 3 is 2y. And then if you divide both sides by 2, you get x over 2 minus 3 over 2 equals y. If you flip-flop the sides, y is x over 2 minus 3 over 2. And the slope then of this line is 1/2. Okay, so there's some work to do there. You got to do some work. We're not done yet, because the slope of the line we want is perpendicular to this line. So the slope of the line that's perpendicular is the negative reciprocal of that, right? So you flip that number. 1/2 flipped is 2 over 1, which is 2, and then you make it negative. Okay, so that's our slope. A lot of work there. Okay, now we got a point and a slope. We could plug it into our point-slope form. and chug away. So we have y minus y1, which is -7, equals the slope -2 times x minus x1. So x1 is 4. Okay, so y plus 7 is negative, distribute, right? So -2x plus 8. Solve for y. So y is -2x plus 1. Okay. All right. We also had average rates of change in here. So these are speed problems, right? So it's kind of like a slope idea, right? So anyways, let's look. So f of x is x squared plus 2x. I want to find the average rate of change going from x1 equals 3 to x2 equals 5. Okay, so the formula is the slope formula, basically. But instead of y2 and y1, you have f of x2 and f of x1. Okay, so it's all over x2 minus x1. Okay, so we're figuring out f of 5 minus f of 3 all over 5 minus 3. Okay, so I plug 5 into that thing. 5 squared is 25, plus 2 times 5 is 25 plus 10, so that's 35. So I'm just taking this number here and plugging it into this formula here, right? So f of 5 is 5 squared plus 2 times 5, which is 25 plus 10, which is the 35 that I wrote. Okay, minus f of 3. So let's do f of 3 in the middle to the right of the page. F of 3 is 3 squared plus 2 times 3, which is 3 squared is 9 plus 6, which is 15. Okay, so 35 minus 15 all over 5 minus 3 is 2. 35 minus 15 will be 20 divided by 2, so the average rate of change is 10. Okay, 1.6 is about translations of functions. There's only 2 functions I'm going to worry about you working with, and there'll be problems like 53 to 59, and then 67 to 73. Okay. All right, so the 2 functions will be the parabola, so y equals x squared, and then the other function is a square root function, which is kind of the inverse of y equals x squared. Okay, so problems like 57, I want you to be able to graph h of x equals negative x minus 2 squared. Okay, so you have to, basically I'm going to want you to be able to do horizontal shifts, rotations, and vertical shifts. I'm not going to worry about the stretches and shrinks. Those are always a little bit more weird. So I'll just worry about those 3 things, and you do those in order, right? So for this guy, the minus 2 on the inside will shift it to the right by 2. So I have to go right 2. The minus on the outside of it is going to rotate it about the x-axis. Okay, so x-axis rotate. You may want to start with a little chart for x squared just to get some points. So -1, 1, 0, 0, 1, 1. So that's for just the normal graph, y equals x squared. And then I'll do shifts on those points. Okay. So if I graph the original, I'll put it in a different color so it's clear what I'm doing. So it's these 3 points starting with. Okay. Okay, so I shift this thing over 2 places, so 1, 2. Okay, so the first kind of, put that one in blue. And then I got to rotate this thing about the x-axis. So I'll put my final answer in white. And make sure you label your final answer so I know which one to grade. That's that for that problem. Let's look at another one, 73. So the problem, if you don't put any work with these and you get it wrong, I can't give you partial credit. So I do get partial credit on my tests. I'm not just blindly grading things like a robot. I try to see if you are actually trying to learn the material and maybe just made a mistake, you went the wrong direction or something. What I usually tell students is to at least write this material so I know where you moved. If you want to get really into it, you can do like I did and draw all the different parts and then where you're ending. But really, you only need that final white graph. But if you do that, and you don't show any work, it's not a good thing. You want to show some work. Okay, so if you get it wrong, you get partial credit. Okay, so 73, h of x equals the square root of negative x plus 2. Okay, so this guy, we're going to go to the right this time by 2. Or sorry, what's the order? So yeah, we have to go to the left by 2. So if it's plus, you're moving left by 2. And then the negative on the inside of the function means that we do a y-axis rotate. Okay. And again, if you want to show some work, we could do a little table. What do we have? 0, 0, 1, 1, 4, 2 for y equals square root x. Okay, so I usually just start with that thing. 0, 1, 2, 3, 4, 1, 2, 2, 3, 4, 2 maybe. So 0, 0, 1, 1, 4, 2. Okay, so this is my original. I should have put the original in a different color. Then I want to go left by 2, so I'll put that in red. 1, 2. So my dots all move over by 2. Okay. And then I need to rotate it about the y-axis. Okay, so I'm doing like a circle around that. So this point at negative 2, 0 will be at 2, 0. This point will still be here. And this point at 2, 2 will now be at negative 2, 2. And then was that all my points? Yeah, I only had those 3. Seems like I missed one of them. Oh, this one at 1, negative 1, 1 will be at 1, 1. Okay, so it'll be sitting right there. Sorry. And that will be my final graph, so I'll label that h of x. Okay. Let's move on now. So now we're looking at combinations of functions and composing functions and domain issues. So I'll be looking at problems like 1 to 29 and then 51 to 56. So number 9, we're just determining the domain of this given function. Okay, so we have f of x is the sum of 2 functions. In other words, we have to find the intersection of the domain of those 2 particular functions. In this case, the places where those functions kind of fail will be where the denominators are equal to 0. Right? So we can't have negative 7, and we can't have 9. Okay, so the domain will be everything except those guys. So we'll say negative infinity to negative 7, then unioned with negative 7 to 9, and then unioned with 9 to infinity. Okay. Let's look at another, so number 19. G of x is 1 over square root of x minus 3. So there's 2 issues here. First, you have to make sure the stuff inside that radical, square root of x minus 3, is greater than or equal to 0. In other words, we need to make sure that x is greater than or equal to 3. But also, we need to make sure that the square root of x minus 3 is not equal to 0. Okay, so square both sides. So we need to make sure x is not 3. So at the end, the appropriate interval will be not including 3, so this is the domain, but then going all the way to infinity. Okay, so we have to exclude the 3 from that x greater than or equal to 3 interval. Let's look at 55. And we're doing composite functions here. Okay, so we just want to be able to form these functions and simplify them and note the domain if we have to. I think, do I call for the domain? Well, the domain will be easy here because it'll just be all real numbers, but let's take a look. So f of g of x. Okay, so I'm putting in g wherever I see x. Okay, so instead of x, I write 5x squared minus 2. We got an extra parentheses floating about over there. Get rid of that. So this will be, I can put anything in it. So the domain, first off, is anything, right? Negative infinity to infinity. Now I'm just a matter of simplifying. So what do we have? 20x squared minus 8 minus 3. And then combine like terms. 20x squared minus 8, 9, 10, 11. Set the other way around. And again, I believe the domain will be all real numbers. Okay. So you're putting f of x in for the parentheses. That will be 4x minus 3. So yeah, again, you can put anything in there for x. So the domain is negative infinity to infinity. Let's go ahead and FOIL that. So at the top right, I'll go ahead and FOIL. So I have 16x squared minus 12x is minus 24x, and then plus 9. And then minus 2. And then I got to distribute. So we have 16 times 5. So I have 80x squared minus 24 times 5. 120x plus 45 minus 2. Combine like terms and you are done. 80x squared minus 120x plus 43. Okay, the next section is on finding inverses. Let's go ahead and take a look there. So this is 1.8, and we're dealing with 11 to 27 odd. And number 19, we're just finding the inverse and verifying the inverse. Okay. So f of x is x plus 2 cubed. I need to find the inverse, so replace the x and y's. So x will equal y plus 2 cubed. Take the cube root of both sides, so you get y plus 2 equals cube root of x. Subtract 2 from both sides, y equals cube root of x minus 2, and that'll be our inverse. Okay? So we call that whatever, f inverse g of x. We still need to verify it, right? So I go f of g of x. Okay, so I'm putting this expression in for x and f of x. So I have parentheses there where I'm going to put g of x. So this will be the cube root of x minus 2. And that'll equal the cube root of x minus 2 plus 2 is just 0, so those go away. If you cube root, you just get cancellation there, and you end up with x, which is what we want. And that'll work for all x's in the domain of G. The domain of G is all real numbers, if you're wondering. Okay. And the domain of F is also all real numbers. And so we have g of f of x then. I need to figure this out. Sure, it's the cube root of, we're going to put f of x in there, and then minus 2. Okay, so I'm putting f of x in here. So x plus 2 cubed. And then we have the same phenomenon. The cube root of something cubed, those will cancel out. And you just left x plus 2 and minus 2. And of course, that equals x. And that works for all x in the domain of f. Okay, there's no domain issues here. So if the cancellation equations work, that means g of x is in fact equal to f inverse. Okay, so you have to find the inverse, and then you have to verify the inverse for that problem. But please read directions. Okay? And I'll be taking the directions straight from the book. So if you go into the book, the ebook, and look at the directions, I'll have the same directions on my test. Okay, so maybe I should be a little more careful. Right? Oh, let me have a look. So this is 1.8, and let's see what the directions ask for, right? Let's not be so sloppy. And exercises, so the first one, in exercises 11 to 28, find the equation for f inverse. Okay, that's what we did. And verify the equation is correct by showing the cancellation equations work. And we did that. Okay, and so I didn't even really need that domain stuff. I'll try to be nice about the domains because I know that stuff's complicated. Obviously, in the domain questions like 9 and 19 here, that's serious. I need to know the domain for those kind of problems. But once we get to like inverses, not so much. Okay. All right. So 25 is another one of these problems. You have to find f inverse, and you have to do the cancellation equations. Okay. So this one's a little bit longer. Let's take a look. So I have f of x is x plus 4 all over x minus 2. And so I want to find g of x. So swap the variables. X is y plus 4 over y minus 2. And then you have to cross multiply. So multiply both sides by y minus 2. So you get xy when I distribute. Minus 2x equals, over here the y minus 2's cancel. You want to collect all the y's on one side, all the other stuff on the other. So I have xy minus y. Subtract y from both sides. Add 2 to both sides, 2x to both sides. So 2x plus 4. Factor out the y. Divide by x minus 1. And there's your inverse. Okay. Now we need to verify the f of f inverse works. Okay. Or if you'd rather call it g, that's fine too. So we have f of g of x. So putting in 2x plus 4 over x minus 1 plus 4 all over 2x plus 4 all over x minus 1. Then minus 2. Okay. And technically this has to work for all x's in the domain of g, and the domain of g will be everything except 1, right? So negative infinity to 1 union with 1 to infinity. But it's going to work. Okay, it'll never be an issue. So don't have to worry about the domain issue for so much for us. Okay, so let me simplify that. So it's going to be 2x plus 4 all over x minus 1. I need a common denominator to combine these two parts in the numerator. So 4 is the same as 4 over 1, and then I'm going to multiply top and bottom by x minus 1. Okay, so I get plus, and if I distribute, it'll be 4x minus 4 all over x minus 1, divided by 2x plus 4 all over x minus 1 minus, you can rewrite 2 as 2 over 1 and then multiply top and bottom by x minus 1. A quicker way is just to multiply the everything top and bottom by x minus 1. That would have been way quicker. I apologize. So we get minus 2x minus 2 all over x minus 1. Okay, combine the numerators over the common denominator. So you're going to get 2x plus 4x minus 4. Okay, so 2x plus 4x is 6x. 4 minus 4 is 0, and that'll be over x minus 1. And then that's all over 2x plus 4 minus 2x minus 2. And you have to be a little careful with that one because you have to distribute the negative. Okay. Eventually, we're going to be multiplying by reciprocals. So we have this. I need to distribute these guys. So I'll have 2x plus 4 minus 2x plus 2. Okay, so I have 6x. The x minus 1s will divide out. And so I'll have 6x all over 2x minus 2x is 0. And then 4 plus 2 is 6. And we get x. Okay. All right, let's do the other one. Let me sort of move all this, all this junk. Just move it out of the way. Get out of here. Okay, so now I need to get g of f of x. And I'll do this sort of the other way of simplifying. So I have 2 times x plus 4 over x minus 2 plus 4 all over x plus 4 all over x minus 2 minus 1. Okay, so the quicker way is just to multiply the top by x minus 2 and the bottom by x minus 2. At least I think it's quicker. So when you do the top and you distribute this, the first distribution, the x minus 2's divide out. So you just have 2 times x plus 4. And then plus 4 times x minus 2. Downstairs, the x minus 2 and the x minus 2 there will cancel, and you'll be left with x plus 4. And then this times that will be minus x minus 2. Okay. Now we simplify by doing some distribution. 2x plus 8 plus 4x minus 8. All over x plus 4 minus x plus 2, and then combine like terms, you get 6x, 8 minus 8 is 0, all over x minus x is 0, 4 plus 2 is 6, oh, and we got it. Okay, so in both cases, we get x, hence their inverses. So g of x ultimately equals f inverse of x. Okay, so there's that. Let's move on to 1.9. So I'm looking at problems like 1 to 17 odd, and then 53 to 63 odd. Okay, and what is that? It's a distance formula stuff and circles, equations of circles. So you have to know the distance formula. You have to have that memorized. Okay, and it kind of has a slopiness to it, a slope flavor to it. So you see the y2 minus y1 and the x2 minus x1. So it's a lot like slope. So you kind of combine it somehow and remember it that way. The circle equation is x minus h squared plus y minus k squared equals r squared. Okay, so let's look at some of these. So number 7. You need to find the distance between the 2 points given. Okay. So the distance will be the square root of x2 minus x1, so 3 minus negative 2 squared. Then plus negative 4 minus negative 6 squared. Right. Simplify this material. Equals 3 plus 2, so 5 squared, plus negative 4 plus 6 is 2, so 2 squared. And then that equals 25 plus 4, and then that equals square root 29. We could leave it like that, that's fine. Let's look at 55. So there's a complete the square problem probably. So remember, sometimes they'll give you circles in this form. and you have to put it into the regular form and then graph it. Okay, so to get it into our regular form, which is this form that I first initially drew right here with the arrow pointing to it, to get it in that form, you got to complete the square. Okay, so we want to collect all the x junk, x squared minus 10x, and then we're going to be adding something in, and then plus y squared minus 6y, and we're adding something in. Move the other stuff to the other side, so add 30 on both sides, you get 30, and then if you add stuff to one side, you have to add it to the other. Okay, so what is that thing I'm adding in? It's always b all over 2 squared. Okay, so in this case, negative 10 all over 2 squared is negative 5 squared is 25. If you add it on the left, you have to add it on the right. The next guy, negative 6 all over 2 squared. Negative 6 over 2 is negative 3. Negative 3 squared is 9. Add it on the left. You must add it on the right. Then we can factor. So x minus 5, the first guy is x minus 5 squared. Second guy is y minus 3 squared. On the other side, 55, 64. Okay. And then we can identify the center and graph the thing. The center is 5. You just take the opposite signs, 5 comma 3. And then the radius is the square root of 64, which is 8. Okay. And then I can kind of graph that thing if I'm called upon to read the directions. Okay. Okay, I just put 15 tick marks. I don't know how many I need. 1, 2, 3, 4, 5. 1, 2, 3 is the center. And then you go up 8, down 8, right 8, left 8. Okay, so up 8. 1, 2, 3, 4, 5, 6, 7, 8. It's about here. Down 8. 1, 2, 3, 4, 5, 6, 7, 8. It's about right here. Right 8. 1, 2, 3, 4, 5, 6, 7, 8. It's about right here. And then left 8. 1, 2, 3, 4, 5, 6, 7, 8. About right here. Okay, and then connect the dots. And it should be a circle. I know it's not looking like one, but there it is. Okay, so make sure you're reading the directions and answer all the little questions. I'll try to be nice about the domain issues in the inverse section. I know that's tricky. You do need to be able to do the domain issues in the 1.7 though, so when you have composites of functions, you need to be able to identify the domain. When you have combinations of functions, you also need to be able to kind of identify the domains. What else? So you only need to know the graphs for square root x and x squared, and then we'll be doing only translations, horizontal, rotations, vertical, no shift, no stretches or shrinks. Okay, just the horizontal rotation, and you have to do it in that order. Okay, so it's like order of operations. You first do your horizontal, then do the rotations, then do the verticals. Okay. What else do we need to have? You need to know how to produce a perpendicular slope. So if parallel, remember M1 equals M2. If perpendicular, then they're negative reciprocals. So if you multiply them together, you should get negative 1. For the 1.4, you need to have this material memorized. Okay. If this formula is on there, I will give it to you. Okay, I don't expect you to memorize that. You have to know how to get even and odd functions, so you kind of have to have this definition memorized. You have to know how to do this inequality split, so you kind of have to have that memorized. And I think that's about it. Okay, so like I said, when you go to study, just go in there, like in P7, look at problems 8 and 10, and 23, so you look at problems 22 and 24. I gave you 121 in the review, look at 120 and 122, and you'll be pretty well off if you follow that procedure. And make sure on the test you're showing work. There's no cell phones, no books, no notes. You're not allowed to be surfing the internet during your test. You're not allowed to have another person in the room. You're not allowed to have another person take the test for you. It has to be you taking the test. And okay, I think that'll get us started. I'll talk more about it when I set up the to-do list next week. And you can ask questions, obviously, via email during my office hours or during class. Okay, I hope that helps. I hope everybody does real good on the test. And I'll see you next time. Thanks for watching.